Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about electrolysis, a really important chemical process that's used in industry. It's used to do things like chrome plate on metals. It's used to separate and extract useful metals from the ores. Many different uses. So let's first jump in by looking at the meaning. Electro sounds similar to electricity, and that's exactly what it refers to. And lysis, the second part, refers to split or to cut. So it is the splitting of chemicals, of compounds, by the way of electricity. Now, for the GCSE, you're expected to know how an electrolysis practical is set up. And generally, you'll see something like this. You'll see a beaker, and in that beaker you have some sort of solution, and that solution we call the electrolyte. And this electrolyte contains ions, mobile ions, because it's in solution. Okay, you be careful not to say electrons, because the electrons are of course attached to either metals or non-metals, and so we have to say mobile ions. And in that electrolyte, you'll see resting two electrodes. And normally these are made from graphite. These we call electrodes. And these are inert material, meaning they're non-reactive, because you do not want the electrodes to react with anything else in your solution. Now, one of the electrodes is going to be positive or positively charged, and the other is going to be negatively charged. The positively charged electrode we call the anode, and that's going to attract to it anions, which are negatively charged ions, such as, for example, chlorine minus. The negative electrode we call the cathode, and that, of course, is going to attract to it positively charged cations, which are metal ions, and they're positively charged, such as, for example, sodium plus. And this normally is set up to some sort of power supply, which is going to provide electrons that's going to drive the whole electrolysis process. So you need to know the setup of an electrolysis process, and you will use this normally you get to learn about this in a required practical, and you need to know and be able to label the different parts. Now, the rules of electrolysis are quite simple. There are three simple rules for electrolysis. Rule number one is, if the substance that's being electrolyzed is molten, I'm going to write in shorthand here, then the opposite ions attract to the oppositely charged electrodes. That's the simplest rule for electrolysis. So, for example, if I have an anion, an anode, and a cathode, and in that solution we have just two ions. Let's say we had sodium chloride. I'm only going to have two ions in there. I'm going to have the positive sodium, which is +1, and the negative chlorine. And that's quite obvious of where that's going to go. The chlorine is going to go here, and the sodium is going to go there. Very obviously, they go to the oppositely charged electrodes. Rule number 2 states that if in solution, meaning rather than being molten, it's aqueous, something is dissolved, an ionic substance is dissolved in solution, then the most reactive cation, which of course is the metal ion, stays in solution. So let's look at an example of that. Again, we do our quick electrolysis setup, and we have our anode and our cathode, and we have a solution around it. And let's say we had sodium chloride solution, and I know it's a solution because it's aqueous. Now, instead of 2 ions, I'm going to have 4 ions in this solution. I'm going to have a sodium ion, which is plus. I'm going to have a chlorine ion or chloride ion, which is negative. I'm going to have the ions present in the water, which is dissolved in, which is hydrogen plus and hydroxide or OH minus, because we know that water is composed of H2O, and so that separates. H2O is going to separate into H plus plus OH minus. So now I'm going to have 4 different ions. And let's look at the rule. The rule says that the most reactive cation stays in the solution. Now remember, the cation are the positively charged ions. So that's the sodium and the hydrogen. Which one is more reactive? Well, obviously the sodium, if we understand the reactivity series. That means that the sodium will stay in solution, the sodium ion, and the hydrogen ion, H plus, will go to the electrode, and this will form hydrogen gas, which we'll talk about later. Let's look at the third rule now. The third rule says at the anode, a halogen gas will be formed unless oxygen is present in the anion. Now, of course, we remember in anion. Of course, we remember that the anion is the negatively charged ion. So when we look, for example, at sodium chloride, the anion will be the chloride, which will be a -1. But sometimes we can have oxygen as an anion. So for example, sodium sulfate contains oxygen, which we can see there. If that's the case, if in the anion oxygen is present, that means oxygen will form at the anode. So let's look at an example. We draw our quick setup again. We have our anode and our cathode. Our anode is the positively charged electrode. The cathode is the negatively charged electrode. We have a solution, and let's say that solution is sodium sulfate. That means that oxygen, which is negative, will form at the anode, and you'll see oxygen gas, O2, bubbling up. So with these three rules, we can then understand any electrolysis question that asks what products will form at the anode or cathode. It's quite simple. Now, in order to fully understand what products are formed, we have to understand half equations. So if we had sodium chloride and that was molten, which is liquid, and we did electrolysis, we know that in the solution we have a chloride ion and a sodium plus ion. That will form chlorine gas at the anode, because we remember that the negative ions go to the positive anode. Well, how does that happen? How do we go from negative charge to a molecule which has no charge or is neutral? That means we must lose an electron. So if we lose an electron, we can write it on this side. It's going to liberate an electron. We then need to balance it because there's two chlorines. That means we need two chlorides, and that's going to give off two electrons. For sodium, the sodium plus becomes sodium solid. That's a positively charged cation becomes a neutral charged sodium atom. Well, how does positive 1 become neutral? We need to add 1 electron, and that's done. The half equation is done for that. So you need to understand how to do half equations in order to fully understand how to complete the electrolysis questions. If you want more information, please go watch my video on doing half equations, and that will be really, really helpful.